Welcome to True Projects. In this video, we are going to explain the project wrapper and hybrid feature selection methods using Metaheuristic algorithms for English text classification, a systematic review. Introduction. The internet constantly generates an overwhelming amount of data in today's digital world, including emails, social media posts, and vast text-based resources. Due to its unstructured nature, this text-based data presents difficulties for analysis and accessibility. Businesses and institutions use text classification to address this issue. With a focus on the use of wrapper and hybrid feature selection techniques powered by Metaheuristic algorithms for English text classification, this systematic review explores the world of text classification. In a time of abundant information, this project investigates cutting-edge methods that facilitate effective data analysis, process automation, and data-driven decision-making. Objective of the project. This systematic review aims to improve English text classification using wrapper and hybrid feature selection techniques driven by Metaheuristic algorithms. It uses machine learning models like bag of words, TF-IDF, and various classifiers to provide comprehensive insights into effective text classification methods. The project also aims to create a user-friendly Flask-based interface with SQLite for seamless sign-up and sign-in and text prediction, making the benefits of this project accessible to a wider audience. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements needed are Anukunda 3 and Visual Studio Community version. So these are the algorithms used in this project. The first one is Naive. It is a simple probabilistic model suitable for text classification assuming independence between words. It is efficient and provides a baseline performance for its speed and simplicity. The second algorithm used is Random Forest. It is an ensemble method combining multiple decision trees to enhance classification accuracy and robustness, ideal for handling noisy text data. The third one is XGBoost classifier extension. So, it is an advanced gradient boosting algorithm known for capturing complex patterns and improving predictive performance, making it valuable for diverse text data. The next one is decision tree. It creates a tree-like structure to partition data based on features, offering interpretability and insight into key classification factors. The next one is AdaBoost classifier. It is an ensemble method that combines weak classifiers to strengthen overall performance, focusing on challenging text examples. The next algorithm used is Support Vector Machine (SVM). It is a powerful algorithm for binary and multi-class classification, adept at handling high-dimensional text data by finding optimal decision boundaries. And the next two algorithms used are MLP and ANN. So, multi-layer perceptron MLP and artificial neural networks ANN are deep learning models capable of capturing complex patterns and nuances in text through multiple layers. The next one is K-nearest neighbors KNN. It is a non-parametric method classifying text based on similarity to neighboring samples, useful for text similarity and clustering tasks. The last algorithm used is logistic regression. It is a linear model estimating class probabilities suitable for binary and multi-class text classification with a focus on interpretability. Now we'll discuss the flow of work. These are all the steps followed to build this project. The first step is importing required packages. This step involves importing required libraries and packages like NumPy and Pandas for data manipulation, Counter for counting elements in data, NLTK for utilizing natural language processing tools and libraries, regex for regular expressions, sklearn for machine learning tools and metrics, and matplotlib seaborn for data visualization. The second step is exploring the data set. In this step, we employ exploratory data analysis to better understand the data. The third step is data processing. In this step, we clean, transform, and prepare the dataset, ensuring it is suitable for subsequent machine learning tasks. The fourth step is visualization using seaborn and matplotlib. In this step, we employ seaborn and matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is feature selection using formal data. Here we employ formal methods for feature selection to determine the most relevant features for the text classification task. The sixth step is lexicon vectorizer. Here we apply lexicon-based vectorization techniques to represent text data in a numerical format for machine learning models. The next one is splitting the data to train and test sets. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning while the testing subset evaluates the model's performance on new data. The next step is building the model using bag of words. In this step, we construct machine learning models using the bag of words technique. Bag of words represents text data by creating a vocabulary of unique words and counting their occurrences in each document. This approach simplifies the text data into a numerical format suitable for machine learning models. We employ a variety of classifiers including naive Bayes, random forest, XGBoost classifier, decision tree, AdaBoost, SVM, MLP and ANN. These models leverage the bag of words representation to classify text data effectively. The next step is building the model using bag of words and TF-IDF. In this phase, we develop machine learning models that leverage a combination of two text representation techniques, bag of words and term frequency inverse document frequency, that is TF-IDF. This hybrid approach aims to harness the strengths of both methods. Bag of words simplifies text data by creating a vocabulary of unique words and counting their occurrences in documents, while TF-IDF assigns weights to words based on their importance in each document relative to the entire corpus. Here we are training logistic regression, KNN, MLP and ANN models. The next step is building the model using TF-IDF. In this phase, we focus on building machine learning models using the TF-IDF, that is term frequency inverse document frequency text representation method. So as I mentioned before, TF-IDF assigns weights to words based on their importance in each document related to the entire corpus, effectively capturing the significance of words within the context of each text. And these are the algorithms on which we are training. The next step is training and evaluating the model. In this step, we employ the preprocessed dataset to train previously mentioned models. These models learn data patterns and relationships. Subsequently, we evaluate model performance on a separate test dataset. This evaluation step helps ensure the models are accurate and reliable for real-world use. The next step is Flask framework with SQLite for sign-up and sign-in. In this step, we implement a web framework using Flask and integrate an SQLite database for user registration and authentication. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. Later, users provide English text input which is then preprocessed to prepare it for text classification. The trained models are used to make predictions on the preprocessed user input, and the predictions are displayed through a front-end interface providing users with the results of the text classification task. So, among the three techniques, bag of words, TF-IDF and a combination of both, bag of words proves to be the most effective. And this is the horizontal bar graph comparing algorithms accuracy within bag of words. And we can see MLP, that is multi-layer perceptron, is doing well when compared to all other models in this particular project. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is archive folder in which I have required dataset to train and evaluate models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are model files which contain algorithm information. These files can be loaded into the project code during runtime to utilize the trained models. And these are .ipynb files. So These are Jupyter Notebook files which are dedicated to different text representation techniques, one for bag of words approach, one for TF-IDF approach, and one for the combination of both. These notebooks provide an integrated environment where users can write, execute, and visualize code alongside output results and graphical representations. This is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open the Anaconda prompt. So use the cd command followed by space and then paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python app.py. So I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address and the port unless configured differently. Now copy the local link provided by the framework, and I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up button. Click on it. If we are new users, we have to register first. So fill in all these details and click on register button to register. And if we already have an account, we can directly sign in by clicking on sign in button. As I already have an account, I'm clicking on sign in button. So give the credentials here. I'm giving my credentials. After giving the credentials, click on login button. So it has redirected us to the text classification page. Here we can see a input box where we have to give the input and the application will pre-process it and gives us the classification result. So I have entered an input here and now click on submit button. So this is the given input. So the label, the category type is pet supplies. Pet supplies. So it has classified the topic of the given input as pet supplies. This time we'll give an other input. Click on home button. We'll give an other input this time. So I have entered another input. Now click on submit button. So here we can see it has classified the topic as grocery, garment, food. We'll do the same with another input. Click on home. I have given another input. Now click on submit button. So here we can see the classification as toy games. Click on home. We'll give another one. I have given another input. Now click on submit. So the classification is toy games again. So similarly, we can input any other text and get the classifications. And the conclusion here is this project focused on text analysis and classification using various machine learning algorithms and feature selection techniques. The bag of words approach with the MLP algorithm consistently outperformed other methods like naive-based random forest, XGBoost classifier, decision tree, AdaBoost, SVM, and KNN. The project also explored TF-IDF and a combination of bag of words with TF-IDF. A Flask framework with SQLite for integrated was integrated for user interaction, highlighting the importance of feature selection and algorithm choice in achieving superior text classification results.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.